Okay, so this part is not actually in your notes, but if you'll add it to the summary on the top of the first page, that's a great place to put it. So if we have the equation y equals 3 to the x, it contains the point 0, 1, and 1 comma 3. So we take this number that's the base, and that's where we get that 3. So then if log base 3 of x is the inverse, it contains the points 1 comma 0 and 3 comma 1. Same thing with 2 to the x. 2 to the x contains the point 0, 1 and 1, 2. So log base 2 of x would contain 1 comma 0 and 2 comma 1. So then if we had 1/2 to the x, it's still 0, 1, and then it's 1 comma the base, and this time our base is 1/2. So log base 1/2 of x would contain 1, 0 and 1/2 comma 1. So if you flip to the second page of your notes, you'll see this column, and it says every log parent function contains the points 1 comma 0 and the base comma 1. And it also has a vertical asymptote at x equals 0. So if you want log in your calculator, this would be a good thing to write down. You want to go to alpha, that's your green button, and then window, and number 5. Alpha, window, 5. So let's go to our graph, clear out what we have, and go to alpha, window, 5, and graph this. So it's a base of 3, and then x. And if I graph it, that's kind of generally what it's going to look like. Now we know it's got the point 1 comma 0, and then that little 3 is my base. So I also know it has the point 3 comma 1. And it also has a vertical asymptote at x equals 0. Remember, asymptotes have to be dotted lines. And make sure you have arrows on the ends. And then your log parent function is going to come around and look like this. It's not going to touch that asymptote. It's just going to get really close to it. Your domain for all of these today is going to be 0 to infinity. Remember, we have a parenthesis because it doesn't actually touch 0. It just gets really, really close to it. And then your range is all real numbers. And that's kind of what our calculator graph looks like as well. So if I graph this one, my base this time is 1/3. So I know I'm going to have the point 1, 0, but then I'm also going to have the point 1/3 comma 1. And I've got an asymptote right here. If you want to go to your calculator and see what this one's going to look like, instead of a 3, you can just do 1 divided by 3 and hit graph. And now if you notice this time, this one's going to go from the top down to the bottom. And that's because our base was a fraction. Your domain is still 0 to infinity, and your range is all real numbers. So for this one, you're going to have the point 1 comma 0, and then your base is 4, so you're going to have 4 comma 1. 1, 0, and 4, 1. Your asymptote hasn't moved yet. And connect your dots. Again, domain is 0 comma infinity, and your range is all real numbers. Now, when it comes to transformations, these are pretty normal. If you have a number in front, it's either going to be a vertical stretch or a vertical compression. Remember, if it's a fraction, it's a compression. If it's a number bigger than 1, it's a vertical stretch. And if we have a negative in front, that's going to be Roxa, which is reflect over the x-axis. That b is always just your base. That's not a transformation. But remember, in parentheses, this lies to you. So if it's minus, it's going to go right. And if it's plus, it's going to go left. And then off the end, the plus goes up and the minus goes down. So on the last page of your notes, we're going to look at what those transformations actually do. So it says the parent function f of x equals log base 7 of x is translated right 2 units, down 3, vertical stretch by a scale factor of 2, and a reflection across the x-axis. So we're still going to have f of x equals. The reflection across the x-axis means we have a negative in the front, and the vertical stretch by a scale factor of 2 means we have a 2 before we write the word log. That base never changes. But I'm going to add a parenthesis here because I need to show that it went right 2 units before I show that it went down 3 units. And that's what that would look like. So y'all, just plug this next section into your calculator. Again, remember it's alpha, window, 5. So this graph that's given is the parent function. So basically this is already giving you log base 3 of x, and we just want to transform it. Now, if you just want to use the points that you know that you have 1, 0, and then you know you have 3, 1, this minus 3 takes it right 3, and that plus 1 goes up 1. So if you want to just go right 1, 2, 3, and up 1, and then write 1, 2, 3, and up 1, you can totally do that. Remember, your asymptote started at x equals 0. But now, because your graph went right 3, your asymptote is also going to move right 3. And this is what your new graph looks like. Now, could you have just plugged it into your calculator and looked at your table and gotten those values? Absolutely. It's just whichever one you prefer. It's easier when you've got a stretch or a reflection to use your calculator. So let's look at B, and we are going to use our calculator for that one. So get yourself a negative, and then do alpha, window, 5, with a base of 4, and then x. Now notice, y'all, that minus 5 is not in parentheses, so it's super important that you put it outside the parentheses on your calculator. And then hit graph, and let's see what that looks like. So since I didn't go left or right, my asymptote is not going to move, so it's still at x equals 0. So when you go to your table, don't worry about those errors. Only pick whole numbers because that's what's easier to graph. So you have 1, negative 5, and 4, negative 6. And then if we look at our picture, we can tell that it's kind of upside down. It's upside down because it reflected over the x-axis. So your domain on this one is still from 0 to infinity, and your range is all real numbers. Let's go back up to this one and do the domain. This time, since our asymptote moved to 3, our domain is from 3 to infinity, and your range is still all real numbers. On C, which is the last one, you can still use your calculator. So type in 2 alpha window 5, get your log base 1/3 of x. That minus 2 is in the parentheses, but then the plus 3 is outside. And let's hit graph and see what it looks like. Now, can y'all tell how my asymptote has moved? This transformation right here, where it went right 2, means my asymptote is going to move right 2. So I'm going to draw that first so I don't forget that that's changed. So 3, 3 is going to be a good point for us. And then let's find another one that's not a decimal. 5, 1. It's going to go upside down because my base is a fraction, and that is what it would be. Now, my asymptote is at 2, so my domain is from 2 to infinity, and your range is all real numbers. And that's it.